On today's network, there are many reasons for traffic analysis that include troubleshooting, network problems, intrusions detection, and forensics. And to gain a better understanding of protocols, Wireshark is a powerful packet analysis tool where you can capture, display, and filter traffic live from a network interface. Network administrators, developers, security analysts, students, and building automation control specialists can all benefit from using Wireshark. Network administrators have long used Wireshark to monitor network traffic, to resolve bottleneck issues, and it can help to build you firewall rules. A new player with Wireshark are developers. Developers can benefit from understanding protocols and application behavior. They can see how the routines behave and see if the application works they was anticipated. They can also determine if it's the application or the network that causing slow response times. Security professionals find that Wireshark is valuable resource. For example, if they suspect malicious activity, they can look at the conversations and see if there's a strange port number. They can then do a Google search and determine what program uses that port and determine whether it's malicious or not. Using Wireshark can help students to better understand many of the common protocols used on a network today. They can then study the behavior of protocol. We will all familiar with the 4 packet exchange in the DHCP process, but if you drop it into Wireshark, we can actually see the exchange of the discover, offer, request, and acknowledge. And then we can drill down in each individual packet to see what is happening. With the proliferation and expansion of smart buildings, controls technicians will find packet analysis invaluable as they can monitor traffic used for building automation using PACnet or Loanworks. For example, we see here PACnet stack services, and in this exchange, the control technicians might bring up a flow graph, and here we can make sure that we are communicating with the correct host. The technician can then possibly follow either a UDP or TCP stream to see if the correct commands are at play. Wireshark is a free protocol analysis tool. It's rich in features and it used to examine traffic either live from a wired or wireless connection or by using pre-captured packets. We can analyze network problems, detect network misuse, perform regulatory compliance through content monitoring, the parameter and endpoint traffic. We can monitor bandwidth usage per application and processes, and we can verify endpoint security status to see if there are any unwanted protocols such as SSDP traffic and multicast DNS, and we can gather and report network statistics. So now you are ready to download and install Wireshark. Head on over to the wireshark.org page where you will see this screen. Now here I will just click on this download. Get started now. First we will see this stable release, which is what I have selected and I already downloaded. Within this section you can see the Windows installer for 64 bits and also 32 bits. But then there is also one for Mac OS and others. Now what's important is that you'll want to keep the most recent release on your machine. Now why is that? Well, people submit bugs to developers all the time and they then do their best to fix as many issues as possible. So when you get an update, you will get a release with certain functions that have been enhanced and also bugs that have been fixed. Now you can also select old stable version here as well, which is of course an older version. Now here I will just click on this downloads page. It look a lot like what we just saw, but now let's take a look at bit further down. Now you can see there are a lot of options here. What really great is that Wireshark can be installed on a number of different platforms, including Arch Linux, Novell, Red Hat, and a lot other. And why? Well, a lot vendors are incorporating Wireshark right into their devices. So now let's just click on this window installer 64-bit. So, and if you have any other operating system, you can just select that one. Now I already downloaded the window installer 64-bit. So now once you open the setup, you'll see this screen. So here I'll just click on next, and you'll also see this stuff here, and you can just read this if you want, but I will just click on note it. And then here is the next page where it says to choose the component, and we will drop this down, and you can see some of the plugins and extensions, some of the tools, documentation, T-Shark and Wireshark. Now in most cases you will want to keep all of these, including the plugins and extension, and that's really kind of important because that's how the decodes work. The dissector plugins is what gives Wireshark the ability to present the protocols. You will also see T-Shark. Now T-Shark is lightweight command line interface where if you need to do a large capture, this might be your choice because there is no graphical user interface. It's nice lightweight program. You can do your capture and then bring it into Wireshark for analysis. So I'll again just click on next, and here you'll see all your shortcuts. You want shortcut in the start menu and stuff like that. You can just check mark this or uncheck this. I'll just go next. Next you can select your destination folder. I'll just go with default and again click on next. Now if you have already installed npcap, then you don't have to install this, but if you have not installed this, you have to install this because this is used for to capture the packet. Okay, so I'll just click on next because I want to install this, and if you don't want, just uncheck this, but make sure you have this installed in your machine. So I'll check this and again click on next. Now again for USB debugging, you can use this USB pcap. So again I'll just check this and install this as well, and now I'll just click on install, and it will run through, and again it may prompt you to do a reboot, but once you are done you can bring up Wireshark and then you will see the spark lines, and then you can start capturing traffic. So now let's take a look at the Wireshark interface. Now when you look at this next generation, you look at it and it seems as if there's not as much going on, and yes, it is a streamlined interface, but there's pretty much everything you need in order to start capturing traffic. Now up at the top you still can see some of the different things as far as menu choices, and some of the icons are available. If they are dimmed out, it's simply because there is no packet to work with those icons, so they are not available. Here you can put in a display filter, in which again you can do once the capture begins or with the pre-capture packet, and then down below it says open. Now once you open a packet capture or save it, it will remain on that open, and then you can take a look and quickly reference it. Now down below is where you see the capture and some of options. Now what these are called are spark lines, and that lets us know that we have an active connection and it's exchanging data. Below capture it says use this filter. Now you could put a capture filter in there. I usually don't because it limits you to only what you are filtering and you miss everything else, but you could if you want to put a filter there. And next here you see is that all interface shown. So if I click on this and if I just unselect this external capture, you'll see it will remove USB pcap, and if I just select this, it will again show this stuff here as well. And one more thing you can see with Ethernet, you can see nothing is happening here because right now we have wireless connection, we don't have connected any Ethernet cable, so there is nothing here. Down below this you can learn more about the Wireshark. You can see this wiki, you can ask question and answer, and you can also see the guide here. Now let's take a look at the USB cap. So again we'll click here and you'll see all the devices here, and here in the USB input device I will just select this mouse and I'll just click on start, and yes. Now this is great if you are troubleshooting and want to know what exactly happening during the connection. Now again I will just stop this and I will close this. And now again we are here in the Wireshark interface. Now if you want to do little bit more, and if you go to this capture option and options here you will see three options: input, output and option. And down below you will see enable promiscuous mode on all interface, and make sure this is check mark. And again you will see this capture filter for selected interfaces. Again you will see all this capture filter here. But let's take a look at output. Now here we can capture to a permanent file, and we ask how would you like this, and the PCAP next generation is generally what I leave it as. But remember that Wireshark only going to be putting it in a temporary file until you save it. Now if you want to capture for any length of time, one thing you probably should do is drop it into a ring buffer, and this would occur right here. Use a ring buffer after how many files. For example, if you are letting a capture run and you put a specific coloring rule in order to look for something on a network, you could just keep dropping it into a ring buffer and it will overwrite those files over and over again. Then we go to the options, and here we can see some of the display option and update list of packet in real time, and I generally select that and automatically scroll during live capture. Now the name resolution, this is where it's going to do a resolution of one of the three things. Resolve the MAC address, it does not hurt to do that. That would give us the manufacturer name, and that just simply comes from a file. Resolve transport names, I do that too, because then it will tell us what application it thinks it's associated with. The resolve network names, I generally don't select that, and that's really because if I did select it, it would be hitting the DNS server a lot and it would cause a lot more traffic. And then down below, stop capture automatically after how much. You would say maybe after so many packet or how much of a capture you want, and you can then begin your capture. So the Wireshark interface looks a little different, but as we see, it does the same thing as legacy and provide us everything we need in order to begin capturing packets. Now I am here at the Wireshark interface. Let's take a look at down below. Here you can see the user guides, wiki, question and answer and mailing list. All are hyperlinks, and we will go to these in just a second. But before that, if we just move here at the top, you will see this help. If I just click on this and I just move to the content, you can also use the shortcut F1 for that. Okay, we'll open this in the Firefox. Now here you will see the list of contents guide. For example, if you want to learn about something, let's say I want to learn about this capture menu. I will just select this. Here you will see the full guide about the capture menu. You can learn lots of things here. And if we just move to the statistic menu, you'll see all the stuff here as well. You will also see the capture file properties, statistic menu items and stuff like that. You will learn a lot of stuff here. So next, if I just click here, next thing here you'll see is wiki about the Wireshark. So if I go to this wiki, again this is the hyperlink and it will move us to this website here. You'll see the complete wiki about the Wireshark here. You'll see information about how to edit the Wireshark wiki. You'll see lots of stuff here. You'll learn about T-Shark and other stuff here as well. So again, move out from here. The next thing here you'll see is questions and answer. So if you want to ask any question in the community, just go to the question and answer link, and here you can ask your question and the community will answer, and you can also answer someone else's questions. Okay, you'll see if I just open any one of these, let's say I just how to know which interface I connected. If I just click on this, you can see this is asked by someone, so you can add your answer here, and you can also ask any question here and someone else in the community will answer the question. You can see ask your question. After that, the last option here you will see is this mailing list. So if I just click on this mailing list here, you'll see all this mailing list here. You will also see this for history enthusiasts. You will learn about the Wireshark history and stuff like that. Effective packet analysis begins with tapping into the network at the proper location to gather traffic for analysis. Tapping into the data stream and what you will see will depend on the network. In today's network, there are two types of Ethernet environments: shared or hub-based or on a switch. If you are on a wireless network, you will go through an access point which is acting like a hub where we can see all the traffic. If tapping into a wired network, you will most likely go through a switch and then you will see only your own traffic. If you want to see all the traffic, we have choices. We can use port mirroring or span, which is switch port analysis. We can also monitor directly on the device, as a lot of vendors are putting Wireshark right within their device, so you can monitor the traffic in real time. You can also use a full duplex tab in line with traffic, and you will most likely need a special adapter. When you launch Wireshark, a welcome screen displays the list of available network connections on your current device. After you choose an interface and begin the capture, the interface gathers up network traffic. All packet analysis tools work in the same way. They gather the traffic, they decode it or break it down, and then display it in human readable format. The first step is to gather the traffic, and before you do this, you will need the correct capture engine. For example, if you are using Windows, you will be prompted to use npcap, and in Linux we use libpcap. If you don't have the correct capture engine, you won't be able to capture the traffic. Keep in mind that traffic enters the network interface card one frame at a time. Packet analysis software converts those bits into readable form for analysis. The heart of this is where the decodings take place. Wireshark was ethereal before 2006, but the main core is still the same. The Ethereal Packet Analyzer, or EPAN, is the packet analyzing engine for Wireshark. Within EPAN, we see that it goes through various stages. The protocol tree dissectors, any necessary dissector plugins, and any display filters. Wireshark and many other packet analysis tools provide option to enhance your graphical experience and will display the traffic in a readable format. I am here with this packet capture, and let's take a look at the interface. When you see a capture, we see that it defaults with the three panel. The first panel is the packet list. The packet list pane is at the top of the window, and it shows all the packet found in the active capture file. Up at the top, we see columns which we can modify. We can make them larger or make them smaller, and I can also add those very easily by right clicking. And for example, if I would like to see version, I'll just check this mark and you'll see this version here. Now keep in mind that every one will have slightly different column headers and choices for column headers. It really depends on how you customize those headers. I would take that off by going back in and unchecking that. But I can also add a column value by going directly into field value. So for example, if I just move into the Internet Protocol version and here in the total length, if I just right click and then just click the apply as column, you will see it will be applied here as a column, and I can just take this off as well. Up here in the packet list over on the right hand side is called intelligent scroll bar. Now using the color scrolls, I can easily and quickly go to the trouble spots. For example, I see this black area here and I'll just click on it and it will take me to the trouble spots. In the center are what's called the packet detail, and this is where you can see all the protocols and the field value of those protocols. As they are dissected, we can do the same thing if we want to and pop it out in a single window. Let's do that. I will go up at the top here and I will click on the frame 73. Now if we take a look at this is helpful. For example, if I wanted to display this up on a screen, and in training we can go through each of these field values. Now down below is the packet byte, and this is actually what we call the xdump, and this is the raw data. It is an hexadecimal, but I could make it in bytes. I can right click and say show us in the bytes, so as a bytes, but there is a lot of information, so I will go back in and I'll just click on show byte as a hexadecimal. Now again you see this layout here, and if you want to change this layout, what we are going to do is we'll go to the edit and we'll go to the preferences, and here in the preferences you will see layout option. If I just click on this, you see we have selected this layout right now, and if I want to change this layout, I will just select another one and I'll click OK. Now you can see the layout is changed, and again if I want to change the layout, again we can go to another layout. We can select other layout here as well, but I will just select the default one and OK. Effective packet analysis goes through several phases. First, we need to tap in at the correct location. Wireshark then gathers the traffic, but you will need the correct capture engine in order to do this. Wireshark then decodes the packet using ethereal packet analysis, which is the core engine for Wireshark. It then displays the capture in a readable format for analysis. While you are working with Wireshark, you can use capture and display filters. A capture filter is applied prior to capture and will only capture what you filter, nothing else. A display filter is used during an active capture or even on a pre-captured packet. One important thing to know is that they are different, and also when you are working with display filters, there are shortcuts for those display filters where you can simply right click, and I will do that during demonstration and show you how to easily get and apply a filter. So let's take a look at the interface here, and I want to just show you one important thing, and why they are different is because this comes from the capture engine and the display filters is within the Wireshark and dissectors and the decodes. So if I go up to the display filter, and well, say for example I want to just display FTP traffic, and it does come up with some choices, but if it is just FTP, I will leave it at that. Now while I was typing that, I think you noticed something. It's red. Now what happens in Wireshark is it's trying to help you. If it's red, it means it won't work. Green means it's good, and yellow means go ahead and try it. It might work, it might not work. And the other thing is, when I start typing, if I were to type a capital FTP, it won't work. It never has, and it may work at some point, but at this point a capital letter on the left hand side won't work. Now I can type FTP and just select that, and I would be able to capture FTP data. But while I am using it in a display filter, I will also capture other types of traffic. Alright, so I will take that off, and I want to just show you something down below here. Well, we will say, for example, if I am only interested in capturing FTP traffic, nothing else. Alright, let's just type FTP. And it does not work. Well, again, that's because they are different. Now on this little green icon here, let's just click on it. I just want to show you that there are some samples in here that you can use in order for you to create a capture filter. Now if we look at the way it's structured, you can see that there are different protocols, different ports. What I'm going to show you is I am going to type TCP, and still does not like it. So let's type TCP port 21. Now that's an FTP port. Alright, so as you can see, I simply put port 21, which is associated with FTP, and now I will go to an open FTP site just so we can see what we get when we capture that traffic. And first of all, I will double click on this Wi-Fi and begin capturing. So let's go to any FTP site. And now if I just move to my Wireshark, and I will stop this here. Alright, so now you can see all I have is FTP traffic. The traffic is no longer coming in, and now we take a look, there's nothing else. So if I need to do some troubleshooting, let's see, I will go to statistic and a flow graph. There is the FTP traffic, nothing else. So I will just close this stuff here, and we will also close this and continue without saving. And I'm going to take that off, so you really don't want to keep that capture filter on there, because it's not going to do us any good, because it will limit anything else I try to capture. Once you have cleared out the capture filter, you might also want to reboot just to get out any remaining filters in your interface, so that does not disrupt when you are going to do moving forward. So I want to open up a TCP example, and once I open this up, we'll just do a couple of things with the display filter. And this is where again you will take a look at apply the display filter. Now there are lots of things that we can do as far as providing a display, and I will just type TCP, and again it's turning green, so that means it's okay, and we will see a lot of traffic in there. But within the Wireshark, there are a lot of really nice shortcuts that I can do in order for me to create a filter. For example, if I just come down here, and here in the transmission control protocol, for example, if I want to see that all the frame which have sequence number 0, okay, so what I'm going to do is I will just, first of all, I will just close this filter, and now here what I'm going to do is I will just select this sequence number 0. I will right click on it, and I'll just select prepare as a filter, and I will click on select it, and it will put this here, but it will not run this. If I just click on enter, now it will run. You will see couple of different frames which have sequence number 0, and again to remove this filter you can just click on this close icon. And if I want to see sequence number raw, then I will right click on this, but this time instead of prepare as a filter, I will just select apply as a filter, and again I'll just click on select. It will apply this as a filter. Again I will just remove this filter, and then you can do some other thing as far as expression. For example, if I just move to the internet protocol version, and this time Here if I want to know that if the header identification number is this one 21555, I will just right click on this and again select apply as filter, and I'll select this and it will show me this one frame here. We can also use operator here. For example, if the identification number is this one, and I can also use operators here. For example, if I just right click on this version and I want to show that thing here, if the version is 4 as well, for example, I'll just select this apply as filter, and here you will see lots of operator, and operator, or operator, and not operator, or not operator. And if I just select or operator, if any one of these filter true, they will show that data here. You can see this one. And again, if I just remove this, we can do this something like this as well. If the identification number is for the header is this one, and also the version is 4, only show that one. It will show this one only here. So there are lots of different shortcuts that you can use, and in addition you can create an expression by going to analyze display filter expression, and here you can build your own expression. Make sure you know what you are doing. So I'll close this, and now I have given you just the highlights to show you that we can filter on many different field values, either by using a capture filter which only limits us to whatever I filter on, or better yet, use the display filter, allow the capture to occur and display only the traffic you want to see. In addition to understanding what the protocols do, a solid understanding of the OSI model and the encapsulation process is important to do effective packet analysis. The 7-layer OSI model standardizes the function of data transformation by breaking it down into layers, and it outlines how that network interface card encapsulates the data as it's prepared for transit on the network. I will take a look at the OSI model at a high level. I will review each layer and I will describe the main function. We will talk about some common protocols in that layer and state the protocol data unit, which defines the shape of the data that it's in that layer, and we will talk about any addresses that are needed, such as MAC address or IP address. Let's start with the application layer. Application layer is layer 7, and this is all about initiating contact with the network. Usually a user who would initiate perhaps getting a web page. The protocols that are used are HTTP, FTP, or SMTP. The protocol data unit at this layer is simply data. Nothing magical has happened. It's just simply data, and there is no addresses that are needed. The presentation layer will take the next step. It will format the data. It provides optional compression and encryption, and the protocol data unit at this point is simply data. Layer 5 is the session layer. This is all about initiating, maintaining, and tearing down a session. Again, the protocol data unit at this point is simply data. Now, when we go to the transport layer, this is where we start the encapsulation process. The transport layer is responsible for transporting data. Depending on how you need it transported, you might choose a connection-oriented protocol such as TCP or connection-less protocols such as UDP. The protocol data unit at this point is a segment, and at this point we need a port address. We need the source and destination port address, which will logically associate with an appropriate application. The layer 3 is the network layer. This is all about the network. We provide addressing and routing, and when we talk about the different protocols that are in this layer, we know of course there is IP, and of course we also need ICMP. But let's take a look at that protocol that I put right in between layer 3 and layer 2, which is address resolution protocol. Now address resolution protocol is a unique protocol, and that there is no IP header, and that because it's where it needs to be. There is no routing involved. It's simply resolving an IP address to a MAC address. The protocol data unit at this point is a packet, and the address is an IP address. Layer 2 or the data link layer is all about the proper frame formation. The protocol is Ethernet 2, which is the most widely used protocol on the local area network, and the protocol data unit at this point is a frame, and the address is a MAC address. Now it's all ready and packaged up. It's encapsulated with proper frame formation, and it has all the necessary addresses. It then is broken down into a stream of bits, so it's able to be transmitted on whatever media you need it to be transmitted on. There are no addresses and no protocols involved. Again, it's just sending it off on a stream of bytes. So if you aren't already familiar with the OSI model, get a better understanding of each of the layer of the OSI model. What it does, the protocol data units and the addresses, all in all, these skills will help you to analyze traffic better. Now that you understand the different layers, let's build out a frame. Now when frame formation occurs and the encapsulation processes take place, we start out with a stamp of data. Well, the data might be a web request. The next thing that happens is we create a segment, and that would either be your TCP or UDP header. And within that segment, we have the source and destination port address. Next part of encapsulation is adding the IP header. Now at the network layer, it's called a packet, and within that we have a source and destination IP address. The last part of this frame formation is the frame header, and within that, of course, we have the MAC address. And with the frame, not only is there a header, we also have a trailer. That is the frame check sequence. This is to provide error detection on a network by creating a cyclic redundancy check value that the network will check as it's traveling along its way. Now, if we look at that frame formation and the encapsulation process, we can relate it to how it's presented to us in Wireshark. So take a look at this encapsulation, and all the way at the top is of course your frame header. Frame is Ethernet 2, and you see the source and destination MAC addresses within that frame header. The next represents the network layer in the form of a packet. And there you see the IP header, and of course within that would be your source and destination IP address. And then we move to the transport layer, where you see a segment. In this case, it's transmission control protocol, and there you have the source and the destination ports. Tucked within that frame is the data, and here we see HTTP, and it might be a web request. Keep in mind, not all frames have data. This is an example of fully encapsulated frame, just to show you how it relates in Wireshark to the OSI model. So it's important to understand the OSI model because the encapsulation process is evident in Wireshark, and understanding each of the layers, the protocol data unit and the addressing will help you to analyze traffic better. The TCP IP suite or Internet suite is a set of protocols that allows us to communicate and exchange data on the network. The suite defines how data is packetized, addressed, transmitted, and routed. The key protocols are TCP, UDP, IP, and ICMP. We see the TCP IP suite residing here at the network and transport layer. At the network layer, the main players are IP and ICMP. IP or the Internet Protocol is the network layer protocol used for routing the data from the source to the destination. IP is responsible for addressing and does not have any error reporting functions. For that, we use ICMP. This is used in addition to the Internet Protocol to carry error. routing and control messages. However, it does not exchange any data between systems. The transport layer provides data transport by using either TCP, which is a connection-oriented protocol, or UDP, which is connectionless. You will hear that other protocols ride on the top of the TCP IP suite, and those would be protocols such as those in the application layer, HTTP, FTP, or SMTP. And we need to set in our bindings the ability to use TCP IP as pictured here in this graphic. The TCP IP suite or the Internet suite is a set of protocols that allows us to communicate and exchange data on the network. Transmission Control Protocol resides at layer 4 or the transport layer of the OSI model. Transmission Control Protocol provides connection-oriented transport. TCP begins with three-way handshake and data is sequenced and acknowledged. TCP supports windowing and flow control so as not to overwhelm the host with the TCP header. And now we will go into Wireshark and take a look at those field values. Now if you want to follow along with me, you can just go to the Wireshark wirecloud http.com and just simply download this. Just click on export and click on download and bring this into the Wireshark. Now first of all, here what I am going to do is, you will see three panels here. Now what I am going to do is I will go to view and I will just uncheck this packet bytes because I want more landscape here. Okay, so I will hide this and then simply I will just click on frame 4. Now let's just take a look at our encapsulation. Frame 4 is simply metadata about that frame. Here is the frame header, Ethernet 2, the network layer header IP, the transport layer header TCP, and then the data HTTP. We are going to open the TCP. Now we can take a look. I will float this on top so you can refer to the TCP header. Alright, first we see the source and destination port. The source port is 57678. Now send from the client. That's simply saying when you come back, send the data to 57678. The destination port is 80, which is associated with HTTP. Here we see stream index 0. There are no field value stream index. That's the value calculated by Wireshark. This helps you to keep track of the many different streams in Wireshark. And if we were to look at conversation, we could go to stream index 0 or stream 14 or whatever you would like. Here we see TCP segment length 134. Now where did that value come from? If I just scroll down here and I will just place my cursor on top of this HTTP header, and here you see 134 bit. Again, that's just a number calculated in Wireshark. Now here we see sequence number 1 and its relative sequence number. What that means, it is in relation to this stream sequence number 1. It's not the actual value. If it were, it's large number. Let's take a look. I will right click on this and I will go to the protocol reference. And here we can uncheck relative sequence number. And as you see, it's a large number. It's very hard to calculate values with that large number. So we'll go back to relative sequence number by going to the protocol references and we will check this relative sequence number and then we will put relative sequence number back. For example, it says next sequence number 135. Well, that's 134 plus 1 and that's what the calculated as what coming next. Here you see the acknowledgement number 1 and again its relative acknowledgement number. And now here is the header length, 32 bytes. Normally a TCP header will be about 20 bytes. Now when we add option, that adds to length. Now let's take a look at the flag section. Now there's a lot going on with the flags. When you are ready to go a little more advanced, You can find out about all the flags, and why we keep track of those is certainly your devices are monitoring what's happening during the conversation. The flags tell the story about what's going on at that point in time. Now some common ones that you will see, of course, is the SYN flag, and that's going to synchronize the sequence number. We see acknowledgement, and that's of course acknowledging the data push. And the fin flag is when the conversation is over, we exchange fin packet. And reset is when it's set. It means I don't want to talk to you and the conversation has reset or closed. So a lot goes on with flags, and it would be good to get familiar with those as you advance, because it tells a lot about the story and it is used for a number of different reasons. Next, right now we will go to the window size. Now window size, it says 46, but then there's a value here in bracket, it says calculated window size. That's larger number. Well, that's because the actual value is pretty small, and in the 80s the window size of 46 would maybe a normal, but as you see there's a scaling factor of 128, which give us the true value of 5888. That's so the server knows about how much data I can send to the host without overwhelming the host. It will update if the value goes up or down. For example, if the host buffer were to get too full, the number would shrink, and as it processes the data, the number would then expand. Now we will look at the checksum. It says unverified. Well, in a lot of cases you will find that we are not going to try to validate that checksum, and here's why. Now take a look down below, there is a blue dot, cyan dot, and that's the expert system. Now what is it saying is that it's just chat. Okay, so if this were to be calculated, this might be incorrect, and I will show you why. We'll go to the protocol preferences, and here it says validate TCP checksum if possible. Now I will select that, and now you see it says it's incorrect and it should be this number. And as you see, there is little note that says TCP checksum offload. What happens is it offloads to the NIC card and it comes up incorrect. Down below you see the red dot and the expert system, and that's saying that there is possibly something wrong with this stream, but there isn't. So we'll go back and check that and replace that with validate TCP checksum. So again we'll go to the protocol preferences and we will click on validate the TCP checksum if possible, and that will correct that. But if the checksum is important to us to use because it's going from source to destination, many things could happen. The checksum in the TCP header monitors for error detection, not correction. Now we will see the urgent pointer, and then down below then what follows as you see over is option and data. Well, now here you see the option, and in this case that option is 12 byte. Now we know that it needs to be a multiple of 4, so let's drop this down and see what inside. Well, you see there is timestamp option, and that's 10 byte, but it has to be 12. So you see no ops, which are kind of placeholder, so that comes up to 12 bits. So that's the TCP header in Wireshark, and we have gone over all of the field values and hopefully have got a little better understanding of TCP. Transmission Control Protocol is a connection-oriented protocol. It begins with a three-way handshake and ends by terminating the session. A three-way handshake begins by the client sending a SYN packet to the server. That SYN packet synchronizes the sequence numbers. If the server accepts, it responds by synchronization acknowledgement. The client then sends a final acknowledgement, and then we have a connection. A socket is created and we can begin to exchange data. Periodically, services will be refused and then you will see a reset. No response may indicate a firewall. You may receive an ICMP destination unreachable packet, and a code might indicate the network was unreachable or the host was unreachable, but most likely the target port was firewalled. the host might try again with another SYN packet. The connection can be terminated in one of several ways. The connection can time out and will be closed, or no password was sent, so the connection was reset, or we will see an exchange of FIN packet and this indicates a normal termination. For normal termination, we simply see an exchange of FIN and FIN ACK packet from the client to the server and the server back to the client, and this will close the connection. So let's step through the handshake and termination. I am here on Wireshark, and you can either follow along in Wireshark or you can go into export and download the file and open this in the Wireshark. So I'll go to the Wireshark and bring that file there. Now I have opened this capture in Wireshark and it's almost a perfect example of complete conversation. I will scroll up here so you can see that it's really a small capture. But let's take a look at flow graph. We'll go to the statistic and we'll go to the flow graph. And there is no need to filter it because its entire conversation is simply with the client to the server. Now let's take a look at the top 3 packet. There you see your 3-way handshake, and then down below you see an exchange of data, and then somewhere in the middle you see quit and closing connections. So we now know it's time to terminate this session, and the last 4 packets are where we close the conversation. So I will close that, and let's take a look at the 3-way handshake. I will scroll up and give us a little more room where we can take a look at the frame 1. So let's just first start with the frame 1. Now when we look at frame 1, we have a frame header, we have the IP header and the TCP header. As you notice, there is no data. There won't be any because it's just a handshake. No data is exchanged. And you can also see here length equal 0. So let's take a look at the TCP header. This indicates what's going on. If we take a look at the flags and drop this down, and here you see the SYN flag set. Again, that's from the client to the server trying to initiate a conversation. Now with that first packet going from the client to the server comes with its some options. If I place my cursor on the TCP header and then look down below, the TCP header is 40 bytes. The TCP header is 20 bytes at least, but with option it's more. Now at this point it's 40 bytes, but let's take a look at the option. Here's your option, and I will drop this down and you can see what it is. Is the client communicating to the server what options would I like to agree upon, and so you understand. For example, the following client is seeing that the maximum segment size is 1460 bytes. Also SAC is permitted, and SAC is selective acknowledgement, meaning keep sending the data even if it's not in order. I'll put it in the correct order. Here we see the timestamp and window scaling. Now keep in mind it has to be multiple of 4. Now with each of these, and if you look down below, you can see the size of each of those options. Window scaling is 3 bytes. So we have to add a no op, which is essentially a placeholder to bring that total up to 20 bytes. And then that with the TCP header give us our 40 bytes. The server then responds with the sync acknowledgement. And I will scroll down here, and here you can see the acknowledgement flag. If I just move to the flags, and you can see the acknowledgement flag and the sync flag. Now keep in mind that sync flag is set only on the first 2 packet of 3-way handshake. After that you won't see again in that conversation. Now we will bring this up and take a look at the TCP header, and again it's 40 bytes because the server is sending the server option, and as you can see those are the following option the server sent to the client. Then we go to the frame 3. And that's our final step in this. And let's take a look at the flags here. Now we see that the acknowledgement flag is set, and that means the conversation is ready to begin. After this, we can start to exchange data. In this point, you can see the TCP header is dropped to 32 bytes because there are few less options, as you can see down below. Now we'll bring this back, and now we'll take a look at the end of the conversation down below. We'll go to the frame 12, and here's where you see the exchange of data from the client to the server. Now it's seeing an acknowledgement, and that acknowledgement is probably at the end of the conversation, where the client is saying that it's acknowledging that it's received whatever data it's received from the server. The server respond with fin acknowledgement saying, I am pretty much done with everything, we can close this connection. Then the client respond again with the fin acknowledgement, and then we see our final acknowledgement, and that will then close the connection and terminate the session. So as you can see, TCP is a connection oriented protocol where you will see a three-way handshake and a tear down of the session.